Hey, what's up, 8th grade? Mr. Catlin here, helping you out with your final lesson of the week for your homework that's due tomorrow. We don't have a quiz tomorrow, but we are going to do lesson 5, but we don't have homework that's due for it. So that'll just be something we do in class tomorrow. But this is due when you walk in, so have it ready to go. Lesson 4, we're looking at square roots. Where do they land on the number line? All right. And so we're approximating what square root of 18 equals. Square root of 18 is a number that's a decimal that repeats forever. There's no way to know exactly what it is because it goes on forever. But we can approximate where it's near on the number line between what two whole numbers. And a good way to do that I've been trying to coach you through, is to know what your perfect squares are. Perfect squares are uh, square root of 1, which is 1 times 1. And then think, okay, 2 times 2, what's that? Well, that would be the square root of 4. And then 3 times 3, which is the square root of 9. 4 times 4, which is the square root of 16. 5 times 5, which is the square root of 25, and so on and so forth. We could keep going all the way up to our 12s if we wanted to, because those are the ones you should know off the top of your head. But we can stop because 18 is the one that we're approximating. So we ask ourselves, well, which of these two square root numbers does 18 fall between? Well, it falls between 16 and 25. So we know that the square root of 18 will be between the whole numbers of 4 and 5. And another way to visualize this is why I drew this grid on here for you so you can see it. If I have a square that's 1 by 1, it's got one square inside of it. So its square root has to be square root of 1. The side is square root of 1. If I've got a square that is 2 by 2, you can count 1, 2, 3, 4. There's 4 blocks inside. If I've got a square that's 3 by 3, then that's got 1, 2, 3, 4, 5, 6, 7, 8, 9. It's got 9 blocks inside, so its side length is square root of 9. So this just matches what I wrote over here in visual form, right? This block right here is a square that has 4 by 4, and it's got 16 squares inside of it. So this is really just the same as the square root of 16 as the side length side, right? And then we could go one more time and show you that a 5 by 5 would have 25 blocks inside of it. Hence, its side length is 5, or the root 25. Now, the one that we're trying to plot on here is the square root of 18. So when you're trying to plot this in between these two, you're thinking, okay, does 18 fall closer to 16 or closer to 25? And something that I think is helpful is if you actually draw a number line of these two numbers, 16 and 25, and you can see that they're 9 apart from each other. So if you make 1, 2, 3, 4, 5, 6, 7, 8 tick marks in between them, okay, because this would be 17, 18, 19, 20, 21, 22, 23, 24, 25, right? Now, if this is the square root of 16 and this is the square root of 25, which is 4 and which is 5, the square root of 18 would be 17, would be right here. This would be the square root of 18, right? Now, think about in between 4 and 5. You see how it's closer to the 4 than it is the 5 because 18 is closer to 16 than it is to 25? So my guess for the square root of 18 is to probably plot it right about here, right? This is our plot for the square root of 18. I hope this was helpful and you guys are able to plot these points and think about what they equal in their decimal form. And I would even approximate, okay, that it's probably about, I don't know, 4.1 or 4.2, something like that, somewhere in between. All right. And that's all I got for today's help video. I'll see you guys tomorrow. Don't forget to bring that homework. This is the last problem that's on there.